Hello and welcome. Today we are going to solve question number 29 on our list of questions. And question number 29 says we should solve the differential equation x squared dy by dx plus xy equals the square root of 1 minus x squared y squared. So to solve this differential equation, I am going to rewrite the differential equation. So I rewrite the differential equation and write x squared y squared as xy all squared. I do a substitution. I say let xy equals to some new variable, call that u. Differentiating this equation with respect to x, we are going to use the product rule. We differentiate x with respect to x, that's 1. So we keep y constant, plus we hold x constant, and then we differentiate y with respect to x, that's dy by dx. And this equals to the derivative of u with respect to x, that's du by dx. Once we've done this, the next thing to do is to solve for dy by dx in this equation. So I send y across. I will have x dy by dx is equals to du by dx minus y. And once I'm done with that, the next thing I will do is to divide each side by x. So if I divide this side by x, I will have dy over dx is equals to 1 over x, parenthesis open, du over dx minus y. Once I'm done with that, I can go to the original differential equation and then substitute these values for their respective identities. So this is the differential equation. I will have x squared. Now dy by dx is this. So I will say 1 over x, parenthesis open, du by dx minus y, plus, what is xy? Xy is u, plus u equals to the square root of 1 minus u squared. I can go ahead and simplify this left hand side. So x goes into x squared, it goes x times. So this is x, parenthesis open, du by dx minus y plus u equals to the square root of 1 minus u squared. By multiplying each expression in the parentheses here by x, I am going to have x du by dx minus, this time this is xy plus u equals to the square root of 1 minus u squared. But remember, from the beginning of our substitution, we said let u equals xy. So this is going to be x du by dx minus u, this is u, plus u equals to the square root of 1 minus u squared. Once I do this, I will realize that u and u will cancel out. So I'll just have x du over dx is equals to the square root of 1 minus u squared. I am going to separate variable from right here. So this square root of 1 minus u squared is going in the denominator of du, and the x times 1 will give us dx. Now we're going to divide by x. So we have du over the square root of 1 minus u squared is equals to dx all divided by x. Once we have that, we'll go right ahead and integrate both sides. So I'm going to have the integral of du all over the square root of 1 minus u squared equals to, this is going to give us the integral of dx all over x. Now if I integrate this, I'm going to have sine inverse of u, because when you differentiate sine inverse of u, you have this. So this integral is sine inverse of u equals, this integral is ln of x plus some constant c. But what is u? So I'll say, but u is xy. xy. So my final result will be sine inverse of xy equals ln of x plus c. This is the solution to the differential equation. And if I send ln of x across, I will have sine inverse of xy minus ln of x equals to c. Thank you very much for watching this video, and We hope you subscribe to our YouTube channel for more amazing content.